This video is for section 9-1, rational numbers as exponents. Rational numbers, remember, are numbers that can be written as fractions, so this section is about exponents that are fractions. It's the first section in chapter 9 where we're going to study exponential functions and something called logarithms. We know that any integer can be used as an exponent of any base. For example, 3 to the first power, that equals 3. Or -2 raised to the fourth power, that equals 16. Or even 0 can be used as an exponent. Any number other than 0 to the 0 power equals 1. And we've even studied negative number exponents, which mean reciprocal. So this is 1 over 5 squared, which is 25. Let's extend the meaning of exponents to every other member of the set of rational numbers by connecting exponents to radicals. Recall that radicals were the topic of chapter 7. Radicals involve square root, cube root, fourth root, and so on. If p represents any integer and r represents a positive integer, then this exponential is equal to this kind of a radical. B is representing some number or variable that is the base. The p over r is the exponent that that base is raised to. Notice this has the look of a fraction. So this is defining for us the meaning of a fraction exponent. It creates a radical where the denominator of the exponent ends up as the index of the radical. And the numerator of the exponent ends up as a power for the radical. Let's use that definition to do some examples. If we have a radical to begin with, like the first one, let's write it in exponential form. But if we have exponential form, like this one here, let's rewrite it using radical form. Okay, the first example, the base is x. We have a radical with index 3. So that creates a fraction exponent where 3 is the denominator of the fraction. The third root of x is the same thing as x to the 1/3 power. Let's do this example here. The base is 6x. Let's create a radical where the index of the radical is 4. So 6x raised to the 1/4 power is the same thing as the fourth root of 6x. Notice how the denominator of that exponent ends up as the index number of the radical. Let's go to this one here. We have 12 to the 3/2 power. Because this index right here, which for a square root is a 2, becomes the denominator of a fraction exponent. And the 3 right here, the power on the 12, becomes the numerator of a fraction exponent. And let's do this last example. See that denominator right there? What does that become when you make radical form? That becomes the index of the radical, 7th root. Now what goes inside there? What's the radicand? It's 10 to the 5th power. Next, let's do some simplifying problems like we had in the last chapter, but make use of exponents to help us do the simplifying. And for some of you, this is a good thing because you might not have ever mastered how to simplify square roots, especially when there were variables and you weren't able just to type in the calculator. So we have a 2 to begin with, but then everything that's inside the radical can become the base of an exponential. So let's copy down what was the radicand and then give it an exponent. Because this is a square root, index 2, the fraction exponent is 1/2. Then we can use our exponent rule where you distribute that power to everything on the inside of the parentheses. So we have 2 times 9 to the 1/2, and then a to the 5/2, and then b to the 1/2, and c to the -6/2. Let's figure out what this makes. 9 to the 1/2 is 3, and 2 times 3 is 6. Then a to the 5/2, b to the 1/2, and c to the -3. Next question. Instead of simplifying like we did in Chapter 7, let's make use of exponents. So this first piece right here can be rewritten in exponential form. It is a to the -1/2. The exponent on the a becomes the numerator of a fraction exponent. The index, which for a square root is a 2, becomes the denominator of the fraction exponent. Then times a to the 2/3. Now use the exponent rule about multiplying letters together by adding the exponents. -1/2 plus 2/3 makes 1/6. So the answer is a to the 1/6. And the last example. First, let's work with the negative exponent, which means a reciprocal. So this makes 16 to the 3/4 power. Next, let's rewrite it like this. 16 to the 1/4 power raised to the 3rd power. 16 to the 1/4 power makes 2, and 2 to the 3rd makes 8. As we did the examples, there were times where I fluently moved in between fraction exponents and their radical meaning in order to evaluate. For example, 16 to the 1/4 power means the 4th root of 16, and that's why I knew it was a 2. Or on this first one up here, 9 to the 1/2 power means the square root of 9, and that's why I knew this made a 3. Let's summarize the lesson. We discussed the connection between radicals and exponents, and the main idea was given right here on the note page. The meaning of an expression that has a fraction power is a root, where the denominator of the power is the index and the numerator of the power is an exponent. This works in reverse. When you have a root like this, you can also write it as a power using a fractional exponent.